As our third session in this project, we are going to investigate the lift, drag, and moment of a NACA 0015 airfoil. Just like the previous projects, we drag a fluid flow block into the blank space and double-click on the geometry. Now, for the first step, we need to create the outline points of our airfoil. To do that, we click on Create and then select Point. On the low left side of the software window, in front of Type and Definition, make sure that Construction Point and From Coordinate files are selected. After that, on the coordinate files, we click on the None and select the files where the coordinates of the airfoil points are saved. It should only be pointed out that the data that exists inside the text file you are importing to the Design Builder software should look something like this, and it should have titles just like the shown table, which are highlighted with a green color. After importing the coordinates of our airfoil points, we click on Generate button. Now that we have imported the outline points of our airfoil, it's time to import the outline curve of our airfoil too. To do that, we click on Concept and select 3D Curve. Just like what we did to import points of our airfoil, we do the same thing here to import the curve too. Now, if you compare this diagram with the diagram that is extracted from the article and presented in the next slide, you can understand that our results are valid. It should only be pointed out that this diagram shows the minus values of pressure coefficient over the position. Now, as you can see in the formulation for two parameters of drag and lift coefficient, you can see that the value of surface plays an important role in correctly calculating these two coefficients. Now, in the reference value section, you can see that the area has the value of 1, which is correct here because the chord length or the main length of our airfoil was also equal to 1. In order to calculate the values for lift and drag force and coefficient, we expand the report section and double-click on the forces button. Under the options section, we select forces, and under the direction vector, we enter the value of x to be equal to 1 since we want to calculate the drag force and coefficient first. And under the wall zone section, we select the wall boundary and then click on print button. In the console tab, you can see the values of pressure drag force, viscous drag force, and the total drag force, which is almost equal to 2.63 newtons. You can also see the drag coefficient, which is almost equal to 0.015. Now, in order to calculate the lift force, since this force is applied in the y direction, under the direction vector, we enter the value of y to be equal to 1 and we set the value of x to 0. After that, we click on print button. Now in the console tab, just like the slide related to the drag force, you can see the values of the lift force and lift coefficient, which has the value of almost 0 since our airfoil is symmetric, and the angle of attack was also equal to 0. You also can view this symmetry in the graphics section by extracting, for example, the pressure contour. To extract the contours, we expand the graphics section and we right click on contours and then select new. In the appeared window under the contours of section, we select the pressure and we click on save or display button. Now in this contour you can easily see the values of pressure in the upper section and the lower section of our geometry is completely symmetric, and that is the reason why we have the lift force value almost equal to 0.
To benefit from Mr. CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.